Hey guys, this is Mrs. Harbin, and we are ready to start Unit 5, Section 6 about direct and inverse variations. Before we get started, let's do a quick review here of distance, rate, and time. A special type of relationship, just to remember, just to see if you remember how to plug in numbers into an equation and solve for a variable. So go ahead and on your own, find the distance if rate is 55 and time is 1/2. And when you plug those in, 55 times 1/2, you get that your distance is 27.5. Well, what about if you know your distance and you're trying to find your rate? If our distance is 171, our rate we don't know, so we'll leave it as r, and our time is 3. How would we solve for the rate? Hopefully you said, well, r is being multiplied by 3, so we're going to divide by 3. And that is exactly right. When we do that, we find that our rate is 57. What about when we're trying to solve for time? Go ahead and plug in and see if you can solve for time. You get 260 equals 65t. Since t is being multiplied by 65, divide both sides by 65, and when you do, you get that t equals 4. Occasionally, though, we're asked to plug in something other than a number, like in this case. We're going to find our distance when our rate is 45. And our time is h. So everywhere we see a t, we're going to write in an h. Because we're solving for distance, that means we want to get the d variable by itself. And as you can see, it's already by itself. That means that we are finished. We don't continue solving until we have a number, although many times we will. In this case, we won't. We do stop when, or we know we're finished when the variable is by itself. So d, or distance, equals 45h. All right, take a look at this one. If our distance is 630 and our rate is s, so we substitute that, and we're solving for t, we know that we're not finished because the t is not by itself. T is being multiplied by s. So when we divide both sides by s, we get the t by itself and find that t equals 630 divided by s. All right, that's just a quick review to introduce us to some direct and inverse variations. Today's objective is that you, the student, will identify direct and inverse variations. You will find the constant of variation for both direct and inverse variations, and you will write and apply function rules for both direct and inverse variations. So let's go ahead and get started with some definitions here. A direct variation is a function in which the ratio of variables is a non-zero constant. We know a ratio is just a fraction, and our variables when we talk about functions are x and y. We're going to translate this to an equation in just a second. Please note, as we'll see later, that graphs of direct variations start at the origin and they are linear, which means they are a straight line. Now let's go ahead and translate that definition into a mathematical equation here. We've said a direct variation is a ratio of variables. It's a fraction of our variables. That's equal to a constant that is not zero, a non-zero constant. The quantities can be said to vary directly or to be directly proportional, and the constant can also be called the constant of variation or constant of proportionality. We're going to say for our sake today that they vary directly, and we're going to use the term constant of variation. But I just wanted you to know that when you hear that word proportionality, we're talking about the same thing. Direct variation equations are written like this. Okay, we said that k is equal to y over x. We said that earlier. Which means if we're solving for y, if we put this in function notation, we've got y equal to k times x, or f of x, which is the same as y, is equal to kx. And we've already said that k is a non-zero number. All right, let's take a look at a table here and answer these three questions. First, does this table represent a direct variation? Typo there, ignore that IO in there. And what is the constant of variation if it is direct? And finally, what is the function rule? Remember we said that direct variations have a constant term where every y divided by x is the same number. So let's see. 7 divided by 1, 7. 14 divided by 2, 7. 21 divided by 3, 7. 28 divided by 4, 7. So every y value divided by every x value gives this constant of variation. And what is the constant of variation? Well, we just said it. It was 7 for every ordered pair. Since we know the constant of variation, we can think back to how to write our equation. Y equals kx, or in function notation, f of x equals kx. So our equation would be written this way. F of x equals 7 times x, or every y value is 7 times the x value. Going back to our chart, you can see that very easily that every y value is 7 times the x value. Let's scroll back to where we were here. Let's take a look at a second example. This time we just want to find the constant of variation. If y varies directly with x and y equals 6 when x equals 3. Well, we're going to go ahead and write our constant of variation here. We know that y divided by x gives us our constant of variation. So let's go ahead and plug in our numbers here. 6 divided by 3, and that tells us our constant of variation is 2. From there, we can write the function rule that y equals 2x, or f of x equals 2x. Now, because we've said that direct variations are proportional, when we're trying to solve real-world problems, we can use proportions to help us solve or find missing information. Because the ratios are in a direct variation, they're always equal to a constant, they're always equal to each other, and therefore they're said to be proportional. Going back to our earlier example, our chart, 7 over 1 is the same as 14 over 2. When you set two ratios equal to each other, they are proportional. Let's use that to find this information. If the distance traveled varies directly with time, and Jose rode 12 miles in 45 minutes, how far can he ride in 2 hours? Well, we know that our distance depends on our time, and we've been given two pieces of information, a first distance and a first time. And then we've been given a second time, and we're trying to find a second distance. The first thing we need to make sure of is that our distance units are all the same and our time units are all the same. Our distance was in miles, so we're going to find our distance in miles. But look at our time. In one piece of information, it gave it to us in minutes, and in the second one, it gave it to us in hours. We do need to make sure that these are the same before we start this problem. So let's go ahead and change our 2 hours to 120 minutes. Once we've got them set to the same unit of measure, we can set up our proportion. 12 is to 45, as distance 2 is to 120. And if you've forgotten how to solve a proportion, all we need to do at this point is cross multiply. So 12 times 120, which is 1,440, is equal to 45 times distance 2. From there, to get distance 2 by itself, we can see it's being multiplied by 45, so let's go ahead and divide by 45. And we get that distance 2 is equal to 32 miles. When k is greater than 0, as we've said, it's a non-zero number, so when it's greater than 0, an increase in one variable, like an increase in the x variable, causes a proportional increase in the other variable. Thinking back to that chart, we had 1, 7, 2, 14, 3, 21. So every time we increased our x variable, we increased our y variable proportionately by 7 every time. All right, that was our direct variation. Let's take a look at our inverse variation now. In inverse variations, the ratio of variables is not constant. So no more y divided by x. Now we have the product of the variables is constant. And you guys are brilliant math students, so you already know product means when we multiply our variables, we're going to keep getting the same constant number over and over. An inverse variation is a relation in which the product of the two variables is a non-zero constant. Let's translate that from English to math here. And we've got the product, so there's our multiplication, of two variables, x and y. It's a constant, k, that is not 0. So that's how we would translate this English definition to a mathematical definition here. We'll take a look at the graph later, but please note the graphs of inverse functions are not linear. They are, in fact, curved, and they do not begin at the origin. When we talk about inverse variations, we can say that the quantities vary inversely or they are inversely proportional. The constant is still called the constant of variation, and we are going to use this term vary inversely and constant of variation throughout our examples and classwork. So there are a couple of other ways that you can write an inverse variation. Right? We've already said that our constant of variation is just x times y, but if we were going to put this in function notation or solve for y, we would write that y is equal to k divided by x, or f of x equals k divided by x. Again, it's a non-zero constant. Unlike direct proportion, where an increase in one gave an increase in the other, in inverse variations, an increase in one causes a decrease in the other. Let's see this in a table so you can see what I mean here. As you can see, an increase in our x's leads to a decrease in our y's, and that makes sense. If our constant of variation was 12, and we know that x times y equals 12, if our x is 1 and our y is 12, we've got 12. But if x increases to 2, our y must decrease to 6. And if x increases to 3, our y must decrease to 4 in order for that constant of variation to be the same. So when we look at this table, you can tell very quickly the answer to this question. It is not a direct variation, it is an inverse variation, because all of these, 2 times 72, 4 times 36, 8 times 18, 12 times 12, and 16 times 9 have the same x times y value, or constant of variation, which is, hopefully noted, 144. Last but not least, let's see if we can write a function rule. As we already stated, the ratio is not constant, so it's not direct variation, but the product is constant, so it is an inverse variation. And since all of our x times y coordinates are 144, our constant is 144. When writing our equation, y equals k divided by x, or y equals 144 divided by x. If we want to switch that to function notation, we would just swap out our y with an f of x. F of x equals 144 divided by x. All right, since we know that the product is constant, we can use this kind of proportion to help us solve word problems. X times y is equal to x times y. Look at this example. The number of census workers varies inversely with the number of days it takes to complete the census. There's our key word. If it takes 24 workers 15 days to complete the census, how many workers are needed to complete the census in 10 days? All right, logically, we know if 24 workers takes 15 days and we want to do it faster, we're going to need more workers. So we should get a number greater than 24. If we don't, we can logically say we did something wrong. All right, let's set up our equation here. We've got workers times days for our first set of information is going to be equal to workers times days in our second set of coordinates because it's inversely proportionate. 24 times 15 then is equal to our number of workers for the second set of information, and we want it done in 10 days, so times 10. We get 360 equals 10 W sub 2. Dividing both sides by 10 tells us that we will need 36 workers to complete that census in 10 days. Remember, the constant is the x times the y, or the w times the d. In this case, 360. All right, I've got 1 minute left, so let's wrap this up very quickly. Direct variation, the ratio is constant. Y divided by k gives you the constant. This implies proportionality. Our function rule is y equals kx, and the graph starts at the origin and is linear. In inverse variations, our product is what's constant. We can find the constant by multiplying x times y, which implies that x times y equals x sub 2 times y sub 2. Our function rule is y divided by, or y equals k divided by x, and our graph is curved and does not start at the origin. Right. Just a quick wrap up. We'll take a look at this in class and talk some more about direct and inverse variations. Make sure you write down any questions that you guys have, and I'll see you next time.